Let's get started going over some practice questions for Chapter 3. In question number 1, we are asked to use the equation and the corresponding graph for the quadratic function to find the x-intercepts. Now we know the x-intercepts happen where the graph crosses through the x-axis. So we look closely at where the parabola, the blue graph, intersects the x-axis. And that happens when x is equal to 2, and it also happens when x is equal to 6. So we use ordered pairs to denote the coordinates of the x-intercepts. So we write our answer as 2, 0 for the first intercept and 6, 0 for the second intercept. For question number 2, we want to use the equation and the corresponding graph for the quadratic function to find the coordinates of the vertex. Now the vertex is located at the very lowest point on the parabola for a parabola that opens up, or it's located at the very highest point for a parabola that opens down. And we can see by closely looking at the graph that this happens when x is equal to 1 and y is equal to -5. So we can write that as an ordered pair in the form of x, y, or 1, -5. For question number 3, we use the equation and the corresponding graph for the quadratic function to find the domain and the range. Now we know that the domain describes all of the x values, and the x-axis goes from left to right. So if you were to look at this graph and as it were to continue forever and ever, this graph would continue to go forever to the left in the x direction and forever to the right. So the domain for this quadratic function goes from -infinity to +infinity. Now the range gives us the values which are described by the y values, and the y values go from lowest to highest. So when we're looking at finding the range, we want to consider how low this graph is going to go, and this graph is going to continue to go down to -infinity. And then how high does that graph go? It's going to reach a high point, and then it's no longer going to increase. So our lowest value is -infinity, and whenever we use -infinity in our domain or range using set notation, we always put parentheses with that. Now this range, this graph goes as high as 3. So the highest that y value is 3, and it does actually touch 3, so we use a bracket at the for that notation to include 3 as part of the range. Number 4, we're asked to match the equation to the correct graph. Now this equation here is written in the form of our basic model equation for a quadratic where y is equal to a times x minus h quantity squared plus k, where the vertex of the parabola can be found by looking at the coordinates shown in the equation h, k, and a can tell us if that parabola is opening up or down. So with just those 2 bits of information, we are likely able to choose which one of these graphs will represent that equation. So by looking at the equation, since it's in the quantity x, since x plus 1 is included in the equation, then we know the h portion of the vertex is -1. And since we have a -4 outside of that, the k portion is -4. And the a in front of 2 means that since a is equal to 2, that means that parabola is going to open up. Whenever that's positive, you have a parabola that opens up. Whenever it's negative, you have a parabola that opens down. So out of all of these, we can see that the one that has a vertex at -1, -4 is either option C here or option D here. And out of either of these, we see the one that opens up is option C. For question number 5, we're asked to identify the vertex of the parabola. Again, this parabola is in the form of f of x equals a times x minus h quantity squared plus k, where the vertex of the parabola is h comma k. Now, because this equation is x minus 7 squared plus 5, we can determine the values of a, h, and k. This would mean that a is equal to 1, meaning that the parabola is going to be opening up. Now, h is going to equal 7, this is x minus h, and we have x minus 7, so h has to be 7. And then the value of k is equal to 5. So the coordinates of the vertex are 7, 5. And number 6, we also want to identify the vertex of the parabola. However, this one is not in that vertex form. So there's another way to come up with the coordinates of the vertex. For a parabola that's written in the form of f of x equals ax squared plus bx plus c, the way we find the coordinates of the vertex is first by finding h, which is equal to the negative b over 2a. For our equation, we know that a is equal to 2, b is equal to negative 8. So h, which is equal to negative b over 2a, is going to be the opposite of b, opposite of negative 8 in the numerator, over 2 times a, or 2 times 2 in the denominator. And when we simplify that, we get 8 over 4, which is equal to 2. So the h part of the vertex is equal to 2. Now we're left finding k. The way that we find k is by evaluating the function at h. So we're going to plug in 2 for x, and what we get out for y is going to be our y coordinate of the vertex, or the k. So we want to evaluate this where x is equal to 2. So it's going to be 2 times 2 squared minus 8 times 2 plus 15. And by using the order of operations, we find that f of 2 will equal 2 squared, which is 4. 4 times 2 is 8. 8 minus 8 times 2 is 16, and then plus 15. So by simplifying that, we get 7. So the coordinates, that's going to be our k. So we're going to put those both together to get the coordinates of our vertex, which is h comma k, is going to be 2 comma 7, the coordinates of our vertex. For number 7, we're asked to graph the equation y equals negative 4x squared minus 2x minus 3. Now, this is in the form of f of x equals ax squared plus bx plus c. So what I always like to do is first graph the vertex, then I can graph a point to the left or to the right of the vertex. Since it's in this form, we use x for the, h for the vertex. Oh, I think I just did something. Sorry about that. We can say that h is going to be negative b over 2a. And using the values in our equation, a is negative 4 and b is negative 2. So it's going to be the opposite of negative 2 in the numerator over 2 times negative 4 in the denominator. So we end up with a positive 2 in the numerator and a negative 8 in the denominator, which will simplify to negative 1/4. Now this is the x portion of our vertex. And we also know from so our vertex is -1/4, comma, whatever we get when we plug in, that k is going to be f of our h, or in other words, it's going to be f of -1/4. So we need to evaluate the equation where x is equal to -1/4 and find the corresponding y value. So when we evaluate -1/4 in our equation for x, we're going to get -4 times -1/4 squared minus 2 times -1/4 minus 3. And when we simplify that, that simplifies to negative 11/4, which is -2.75. So we're going to find the parabola that has a vertex at -1/4 in the x direction and -2.75 in the y direction. And it looks like question number A is the only one out of these that has the vertex in that location. Another thing that we can do to see if our answer is reasonable is looking at the value of A. Now, in this case, A is equal to -4. Since that is a negative, that means your graph is a parabola that opens down. So out of both of these that are, these three equations that are opening down, there's only one of them that has the vertex in the correct location. For question number 8, we're looking at the following. If an object is propelled upward from a height of 112 feet at an initial velocity of 96 feet per second, then its height after t seconds can be modeled by this equation. H of t equals -16t squared plus 96t plus 112. We want to know after how many seconds does this object hit the ground? Well, this equation gives us the height, h of t, so you can find the height at 1 second, height at 2 seconds, and so on. But we want to know when the height is equal to 0, and that's when the object hits the ground. So we can set the equation -16t squared plus 96t plus 112 equal to 0. Now this is a quadratic equation. You can solve by factoring or using the quadratic formula. If you factor out a -16 from all three of these terms, we get t squared minus 6t minus 7. Now this is a lot easier to factor than with those very large numbers. So the factors here are going to be t minus 7 and t plus 1. And using the zero product property, we know that the solutions to this equation, where this would equal 0, would be t equals 7 and t equals -1. Now this represents time, so the -1 second doesn't make sense for this problem. So this happens at t equals 7. In fact, if you plug in 7 back into the original equation for t, -16 times 7 squared plus 96 times 7 plus 112, and simplify, we get 0. So we know that the object hits the ground at 7 seconds. For question number 9, a rock is propelled upward from the top of a building 120 feet tall with an initial velocity of 80 feet per second. The function that describes the height in terms of time is s of t equals -16t squared plus 80t plus 120. Now we want to know the maximum height that the rock reaches. Now remember, we're dealing with quadratic equations, so if you were to model this over time, the rock is propelled upward, it's going to go up and then it's going to come back down. So this maximum height occurs at the vertex. And remember how to find the coordinates of a vertex, where we know that the h and k would be the coordinates of the vertex, where h is equal to -b over 2a. And by plugging in our values, where b is 80, we get -80 in the numerator over 2 times -16 in the denominator. And when we simplify that, we get 2.5. Now 2.5 is not the maximum height. It's actually the time when it reaches the maximum height. So to find the maximum height, we evaluate the function s at 2.5 seconds. So we substitute all the t values for 2.5 seconds. We simplify using the correct order of operations, and we find that we find that this maximum height ends up being 220 feet in the air. For question number 10, we want to use synthetic division to perform the division. Now, I really like synthetic division because it gives us a nice shortcut way of doing these division problems. So looking back at your notes, review this. We know that if we're dividing by x minus 5, then in our setup, we're going to put a positive 5 in the box. And then we list the coefficients, making sure that we have all descending powers of x. So the coefficient of x to the third is 3, and the coefficient of our x to the squared term is minus 21. The coefficient of the x term is 36, and then our constant is negative 30. So this is our setup. Now we're going to perform the synthetic division by always bringing down that first coefficient, 3. Anything below the line, you're going to multiply by the number that's in the box and place it above the line in the next position. And then you're going to add the numbers above the line and place that result below the line. So we have 3 times 5, which gives us 15. And then negative 21 plus 15 gives us negative 6. And now negative 6, we're going to multiply by the 5 that's in the box to get negative 30. And we're going to add the positive 36 and the minus 30 to get a positive 6. And now we can multiply that number below the line by the number that's in the box to get 30. And here we end up with the last number, negative 30, and a positive 30 is 0. This is always your remainder. Now, when you see that the remainder is 0, that means that x minus 5, what you divided by, is a factor of the numerator. And since we divided out an x minus 5, that's going to reduce the powers in our final answer. So we started off with 3x to the third, and our final answer is going to have 3 for the first coefficient, but we're reducing the power by 1. So it's going to be 3x to the second power. Then we use the next result in our synthetic division of negative 6 to use as our coefficient for x to the first power. And then we have our last term is plus 6. Now we don't have any remainders, so we can write this as our final answer, 3x squared minus 6x plus 6.